Good morning, everyone, and welcome to Cup Chat with Birding with Texas A&M AgriLife Extension Service. Today we have special guest Emma Greig joining us. She is with Project Feeder Watch at the Cornell Lab of Ornithology. And so, Emma, tell us a little bit about yourself and what you do. We kind of found you, and I won't even say we. Maureen found you. I'll give credit where credit is due this morning. Maureen found you as she read a paper you wrote, Winter Range Expansion of Hummingbirds as Associated with Urbanization and Supplementary Feeding. I'm a fan of a good title, and I really appreciate you being creative and not super boring on your title. But let's unpack that a little bit. Tell us a little bit about yourself and why you decided to do that study.
Sure. Well, so my role at the Cornell Lab of Ornithology is managing Project Feeder Watch, which is a citizen science program that's been going on now for about 35 years, where people count the birds that come to their yards and submit those counts to the lab. It's run through the Lab of O and Birds Canada. Well, in that 35-year time period, people have just accumulated and amassed an amazing data set of bird abundance across the continent. And that's because everyone's counting birds in the same way. So we have this really beautiful data set of bird population change over time. And so we thought, well, I mean, there are a million things you can do with it. But one thing that stood out when I first started this job was that we knew that Anna's hummingbirds had this tendency to overwinter further and further north, and more birds were spending the winter in the Pacific Northwest, which is it's so counterintuitive to picture a little hummingbird sitting on a snowy branch or feeding from a feeder that has snow piled on it. So it's just kind of a cool thing, but then you got to say, geez, what's going on? How is this possible? And so we thought, well, feeder watch data are really perfect for something like this, because we can look at occupancy, which is the likelihood that a site will have a hummingbird, and something else called detectability, which is, given that a bird is at a site, how likely are you to see it if you look out your window any given day? And we also had information about people putting out feeders or not putting out feeders, thanks to the Feeder Watch data set. So we had all these pieces in place, and we thought, all right, well, let's see what we can do. Let's see what we can do with this. It's just really a small portion of the data set, because Feeder Watch is about all kinds of species.
Well, I think your excitement really translates through your sharing. And you're right, you have all this feeder watch data from people who are doing this anyways. You have all the regular data from eBird, where you know there is or is not a feeder. And to combine that data and make it useful is impeccable.
Well, and I'll just say, it's not data from eBird that tells us if there's a feeder or not. It's data from Feeder Watch. So this was just, the occupancy information and the feeder data came from Feeder Watch.
Wow. Well, and so that's a really good point that I think might be good for our listeners to be aware of, because I know a lot of people already submit to eBird, but that's a different sort of data set. And so you talked about with Project Feeder Watch, you said all the data were collected the same way. So can you talk about that a little bit and how that makes Project Feeder Watch a little bit different from eBird as far as like how the quality of those data, and why, if somebody, even if you do eBird, you might consider also joining Project Feeder Watch?
Absolutely. So I kind of think of eBird as not only does it amass an incredible worldwide data set, but it's also kind of more of a tool for people. You know, however you want to count birds, you can find a way to put them into eBird. That is great for accumulating bird counts. But then when you're a researcher and you come along and you want to look at this or that population change in some species or some suite of species, you have to make sure you are correcting for or filtering out different types of counting, because otherwise you don't know if a difference in the birds is because there's really a difference, or if it's a difference in the way the people were collecting the data. So with Feeder Watch, one of its great strengths is that we send people a counting protocol and we say, count in this way, please. And that way, the backyard counts that they collect will be comparable to all the others that everyone else has collected over the past 35 years. And they can be sure that their data are going to contribute to this large data set. They're not going to get filtered out because it was a different methodology for collecting. So that's part of the strength of Feeder Watch. And there's one other strength of it that I will point out, and it is that it is very much a place-based program. So it is about counting from the same location multiple times within a Feeder Watch season, and hopefully multiple years. We have a few participants who have been doing the program for all 35 years. And
oh my goodness.
I mean, it's just, even if you do it for 5 years, still, then you can really confidently say, look, I've been counting birds the same way these past 5 years, and I can see a change in the number of house finches that I've had, or the number of Anna's hummingbirds. You can really say a lot with those repeated counts from the same place, following the same counting method. So anyway, that's the strength. That's the main strength of Feeder Watch.
That's so valuable. And I really appreciate you sharing that. For, if you're not a scientist and you're not doing this every day, you don't necessarily think about that and that methodology aspect and how important it is. But even, when we think about things, this is something I encourage, like if landowners are managing for a particular species, is that, like you said, there's a lot of ways to do it. But if you're going to compare it, say on your own place across several years, you want to do it the same way. And so then you just scale that up if you're trying to get things like all across the country. But I had a comment to me yesterday. I was doing some deer related stuff, and somebody said, I feel like the rut is earlier this year. I said, well, somebody else had made that comment to me, but 2 observations doesn't necessarily mean anything. But if you are, on your property and you actually document in a particular way, the way that when rut happens every year, then you can go back and look, because our memories are not as good as we think they are, right? Like
they're not.
Fish you caught 3 summers ago is going to be smaller than that same fish 10 years from now, because you just don't remember those things. When you write them down, it's so important. And I think things like Project Feeder Watch, Project Bud Burst, some of those things that really allow us to see the data on those and have them measured in the same way is so valuable. So definitely encouraging people to join Project Feeder Watch.
Well, and I think that that's such you're right. When you talk about how we just want to make these general statements, and my favorite general statement is that the seasons are changing. And, I just think that it's different, and I don't have any data to back that up. And there's people out there who have done the data that the seasons are actually, but see, I just think they're all shifting, because I'm a cold natured person, and it feels like I'm colder longer now, and I don't like that. And so I would much prefer summer and spring get longer and not necessarily winter. But anyways, so you're so true in terms of having that data for your own individual fit place and repetitive, and the importance of that. I love that.
Yeah, and something that can be measured the same way in each place. Because like you said, we don't have an Emily to put in different places across the country to measure how cold or not you feel, right? But we do have thermometers that we can put all across the country. So that's what's great about Project Feeder Watch, is really that repeatability, I think, is fantastic. So, and I think we're going to talk a little bit more about how it relates to climate in a little bit. But before we do, let's break down the results of this a little bit. So hummingbirds expanded their winter range, and you said you knew that going into it, like Anna's hummingbirds were expanding their winter range. And let's talk about what that means. Like, what does it mean to expand a range?
Sure. Yeah, we knew it sort of anecdotally, because people would be seeing these hummingbirds, up in British Columbia, up in Alaska in January, and taking note of it. But so with the Feeder Watch data set, we were able to really document when is this happening? Show us the presence and absence of these hummingbirds in 1995, in 2000, in 2005. So we could show how occupancy was changing through time in northern latitudes, with these little Anna's hummingbirds. And so what it means to have a winter range expansion, what it means is that these birds are, instead of moving, well, Anna's hummingbirds are not really a migratory hummingbird, but they do have smaller movements. So instead of leaving those really cold places and shuttling themselves, down into Washington and Oregon or California, or just staying there all year round, they would stay in Washington and British Columbia and even Alaska throughout the winter. So it just means that they are spending time in places that they used to not spend time. That's basically.
So, and that's kind of interesting for the species of hummingbird too, because here in Texas, we're used to some of the really big migrants, right? Like depending on where you are in the state, we've got species that they're only here sometimes for a few weeks, and they've been way north of us, and they're headed, across the Gulf and way south of us. And so that's different than from the Annas that are making these little movements in the first place, but still used to be avoiding the cold a little bit more than what you see them doing now.
Yeah, an analogy would be something along the lines of Carolina wrens. In Michigan, where I grew up, we never would see a Carolina wren in winter, but now it's not too uncommon to have a Carolina wren poking at your suet feeder or eating peanuts around the holidays. So it's something that didn't used to be there at this time of year, but now it's there. And that's what's happening with these hummingbirds.
All right, and then you mentioned, seeing those birds at your suet feeder or whatever, and this is where these hummingbirds were being counted, is at feeders. So this to me is where we get into the really interesting part, is what were your results from this study? Because this range expansion, you said, was associated with urbanization and supplemental feeding. So how did you figure that out? And then tying into the climate, like Emily was talking about, how did you tease out whether that had to do with the climate?
Well, we just did a lot of thinking about this and thought, well, okay, what would we expect if these birds, let's just think about the climate part. If Anna's hummingbirds were expanding their range north, so moving that northern range boundary to a higher latitude because it's getting warmer, then if you look at the temperature of those feeder watch sites through time, you should see that, okay, well, the hummingbirds are moving north, but they're not actually changing the climate window that they are living in. They're staying in places that are the same temperature. It's that the temperature is marching north. So when we looked at the expansion of the hummingbirds in relation to temperature, what we found was that they were actually moving to colder locations than they used to. So it wasn't that those sites were necessarily getting warmer in winter. It was just that the hummingbirds were able to tolerate colder places than they used to. Now, that's not to say that there is not warming happening, but just at these particular sites and in this particular time window, that did not seem to be the driver of this hummingbird movement. So that allowed us to some extent, rule that out as a real likely driver of the expansion. So then we thought, okay, well, how can we get at this notion that maybe they're associated with people and urbanization? And so for that, we took a little bit of a different approach, and we said, all right, well, let's ask if these hummingbirds tend to be in more urban places in locations that are colder. So at higher latitudes where they've expanded, is their occupancy more associated with higher housing density sites? And then down south, in Arizona and California, where they've always been, how associated are they there with higher density locations, housing density? And so what we found in that case was that in northern, colder locations, Anna's hummingbirds were more tightly associated with higher housing density sites. So more urban sites, they're more associated with people. Whereas down in warmer sites in California, Oh, they would be out in the countryside. You know, they didn't need a lot of people around. They were all over the place. So that gave us a little clue that, okay, maybe it is something to do with people. We were able to say, okay, well, let's look at the hummingbird feeders. What's happening with those? Well, the hummingbirds were much more likely to be seen at sites with hummingbird feeders. That's not super surprising, right? Mm-hmm. But what we could see is that not only were the hummingbirds changing through time and becoming more common at higher latitudes, people over that same period of time were more likely to put up hummingbird feeders. We could see that because feeder watchers will say, I did or I did not have a hummingbird feeder out that year. So you could watch the march of hummingbird feeders follow the march of the hummingbirds. Well, I say that makes it sound like I knew which one comes first. I don't know. We do not know. Is it the hummingbirds that were sticking around and so then people put out their feeders more? Or was it that people noticed the hummingbird and so put out their feeders and then the hummingbird decides to stay? We can't tease that quite apart from this data set, but I suspect there's an interaction happening here. Both we are influencing the hummingbirds and they are influencing us. And so there is this interaction happening between people and this particular hummingbird species that is probably facilitating the fact that they're staying farther north. There's one more little detail I could tell you that actually gets at the behavior of the hummingbirds.
Okay.
Yes, please do.
Now, remember I was saying before that feeder watch data can tell you about occupancy. So that's whether or not a bird is at a site, but also detectability. So you look out your window, how likely are you that day to see a hummingbird? You know one lives there, but how likely are you to see it? Okay, so more southern sites are more likely to have a hummingbird. Higher occupancy in the south, lower occupancy in the north. But where do you think the hummingbirds were more detectable? In the north. Well, this is what's happening here. The birds are more detectable at feeder watch sites in the north. What does that mean they must be doing when these are people looking outside their window at their bird feeder?
They must be using the feeders more.
They're using the feeders more in the north. So just from these bird counts, we could actually get at a little bit of this behavior, this hummingbird behavior. And that is my favorite part of this whole paper. I thought that was so cool that we could see that just from detectability. It sounds so boring of a, some math term, but it's so cool that what you can figure out about what birds are doing.
Well, and it's
that's awesome.
Go ahead, Maureen.
No, go ahead. You're good.
Well, it's just so interesting, and as you talk, you kind of go, let me think about this here. And so I'm going to bring out my livestock background, and we supplemental feed livestock everywhere, all across the country, all the time. And because if we did not supplemental feed in the winter, they would have trouble surviving. The resources are more limited in the winter than it is in the spring and summer. Even in Texas, you supplemental feed more. And so, it kind of is one of those moments where, well, they're hanging around because we're providing them a food, we're providing them the food source that they normally had to migrate for. And now we are providing it for them. If they can tolerate the cold weather, why would they go anywhere?
Yeah, it's very interesting because it's very much like, you would think that if there's more food, they'll stay there. But that's one of those things with science, right? Is like, we can't make those assumptions. We want to have the data to back it up. And so I think that's what's really cool about what you got to do is to say, it seems like if there's more feeders, we'd see them more, that they'd be hanging around more. Or, with those resources, that makes sense when you say it. In southern latitudes, they've got other resources, so we see them at feeders less. But it's so cool to have the data, to have really good quality data to show that.
Okay, I've got a lot of questions. So I know that we have some more questions for you, Emma, but I'm going to sprinkle in some of these questions that are coming in from some of our live viewers. So I am going to go out of order, everyone online. So don't fret. We will get your question answered, I promise. Okay. So this is a two-part question, Emma. Okay. Are there, in your study, did you kind of notice, I know you were specific to Anna's hummingbirds, but are there examples of hummingbirds or other birds contracting their range and not expanding their range?
There sure are. So a cool example of that are gray jays. They're now called Canada jays. Pardon me, the name changed recently. Those are a cold adapted bird that cannot thrive in warm climates because of the way they cache little bits of meat and stuff that will go bad if they're not in cold areas. So that's a species where we've seen a range contraction. They're not living as far south as they used to because, broadly speaking, it is getting a lot warmer in this on this globe. So we can see that in the bird ranges. So cold weather species seem to be contracting. Yeah.
Gotcha. Okay, and then this is the other question that kind of relates to what we're talking about right now is how did you survey for Anna's hummingbirds in non-urban areas away from feeders? So how did you compare that, or was there a comparison?
Well, so they're all at feeder watch sites, but you can imagine that some people that you know live right downtown, and some people you know live out in the suburbs, and some might live way out in the country. Well, any of those folks could be feeder watching. So we can say, okay, is this feeder watcher surrounded by urban habitat, or is this feeder watcher surrounded by countryside? And then given that information, how likely are those different sites to have a hummingbird? So they're all feeder watch sites, either with or without hummingbird feeders, and with a variety of urbanization surrounding them.
So you said you kind of accounted for like the density of housing, right? So it wasn't even just like urban or country. It's like you take into account with the Project Feeder Watch site, like what is the density? And then that gets accounted for when you are modeling that.
Yeah. One of the co-authors on the paper, Eric Wood, he had a really nice data set of housing density that he had worked on with collaborators. And so we overlaid that data set on the Feeder Watch data set so we could have a really accurate, continuous measure of housing density surrounding the Feeder Watch site. So it was a nice collaborative effort. And it shows what you can do with bird counts. You're not limited to just looking at the bird counts. You can overlay climate information, land cover information, whatever you can think of. So there's a lot that can be done with these sorts of data sets.
Oh, that perfect intuition to our next question from our Facebook users is it would be so neat to see a video with heat maps over time showing where birds are being observed. Is that something that's already done? If so, could you provide a link to that? So is that something, where we're seeing the birds over a heat map?
You certainly can. Yeah, with any of these data sets, you can create little heat maps. I have a little heat map animation of the hummingbirds, but I don't know if there's time to bring it up and show you.
No, yeah, you definitely can. Let me make sure.
There's no rules on Cup Chat.
I had to make it so you can share, but you can now.
Okay, you, Emma, look for that, and I'll make Maureen answer this other question.
Okay.
So getting started for feeders. So this is the question. Is there any advice for just getting started? Like how long does it take a bird to find a feeder that's just been put out? And has anyone else noticed general things like fewer birds at feeders this year than last after the snow apocalypse?
So those are good questions. As far as how long it will take a bird to find a feeder, it depends on a lot of factors, but one being like, where are you and what birds are near you? And are there other feeders or resources around you? Because if you don't typically have hummingbirds coming through your area, you can put a hummingbird feeder up and it may take a very long time for them to figure out where you are.
I know. I
Emily's
never,
house.
never.
And yeah, so I mean, a good way kind of to start is to observe what birds you have around you and then know what resources they're going to need. And then you can attract similar species as well. So it's really just going to depend. If you have a feeder up and you're not seeing anything, especially if you put it up at this time of year, this ties into part 2 of the question. It has been very quiet around Texas this year. My anecdotal thought on what happened, and Emily and I are trying to get somebody to come in and talk about weather, but I think that we had a little bit of a cold front and it pushed out our summer species, but we haven't had another big one to kind of bring down some of our winter species. So I think we're like in that weird in between, and there's just not a lot of species. There's just not a lot of birds around right now. So yes, it's quiet. I have no idea if that's tied to the snowpocalypse. Emma might have a better answer for that as far as any of the winter craziness, but I don't know if y'all specifically look at Texas.
We actually have we have a lot of different research questions that we want to do. And one of them is tending to what happened to birds after what are we calling it? The snowpocalypse.
Yes.
That's
what people like to call it when we're not used to snow. Because you said you're from Wisconsin, right? So you're like, it snowed. There's no big deal. But yeah,
Michigan, but there was also that polar vortex in the Midwest, maybe a year or two even before. So we have these 2 really unusual cold snaps that we can look at and relate to birds. So it's on our agenda. We'll see if we can get to it, but
there's never a shortage of research questions, right? Like the having enough questions is never the problem. It's the time and the funding. So
that's exactly right. And I do have this little hummingbird map if you want.
Yeah, you should be able to share it. Go ahead.
Let's see it.
Oh, share screen. All right, let's see if this pops up. You tell me, can you see a little range map?
Yes.
Yeah. So this is a pretty rough animation, but you get the idea. Pink is where the hummingbirds are and gray is where they are not. And it's just toggling from the 90s to the 2000s up till 2013, which was I think that was the last year of data we used for this particular analysis. But you can see where there were none in those northern states, and then they showed up. So there's an expansion.
All the way up into British Columbia, and like not just along the coast where it's a little bit more temperate, but you can see they're like on the other side of the mountains up there where it's quite cold.
Right. Yeah.
So that's really cool. And I think it's a good point that you said too, that the gray is 0, because that's something that if you may not have looked at before, but if people, when you go on to eBird, there's a difference between no data and a 0, right? So it's like, it's important to say it's white because we just don't know. There's no data from there. So it could be there, it could not be, as opposed to like somebody was there, somebody was counting and they did not see any. That's a very important observation. So
it is. We wouldn't have. I'm even going to share that again, because all of the gray is just as important as the pink. And that's from people who didn't see the hummingbirds. So they might think, well, my data weren't useful for the hummingbird study. Those data were critical for the hummingbird study. We couldn't have done it without knowing where the birds were not. And that is something that, it's so hard to wrap your head around when you're looking at your own backyard, but I'm glad you mentioned it because it's so important.
And then tying into the question that about, seeing fewer birds this year is, if you're on eBird and at the end it says, is this a complete checklist of the birds you were able to identify? When you click yes, like if you identified everything that you can see and you're like, I only saw 3 birds today, like, do I even bother submitting the cardinal and, 2 black-crested titmice that I saw? Like, maybe that's not worth it. It is worth it, because especially when you say this is everything I saw, then that's also documenting that you didn't see anything else. And so I think that's so important for people to understand, because especially when it's a slow time of year like this, or just slow for whatever reason, you're like, all I saw was a cardinal. Like, I'm not going to put that on eBird. I know that there's cardinals here. Still put it on there, because it's so important, because it also tells us what's not there. And that's how you document. Like, you can't go out and say, I saw 0 birds today and submit a list with 0 birds. But if you go out and you truly look for all that you can, that's informative as well. So that helps scientists figure out, like, were there really less birds there at that time of year for some reason?
Yeah, you're exactly right.
I'm so laughing at the two of you. Emma, I don't know you that well and we just met today, but I feel like you and Maureen could be like data buddy friends who had coffee and talked about data all day long and love it. So please don't move to Texas, you'll replace me. But we have a couple other questions, and so they are it's just wonderful to have this many questions, so we'll just keep letting them hijack our conversation. So I have to say, I'm going to throw out Brian here. Brian must be really enjoying our cup chat. So Emma, Brian is one of our original birding guides and partners with Birding with Extension, and so he typically does not comment this much on our cup chat, so he must be really loving it. And all I'm going to tell him is he could have just woken up early and joined in and joined us for Cup Chat and asked them live. But so he's asking so in comparison in your study, what do we think is drawing the birds to the urban areas versus the rural areas as they both have feeders? Is it just the density of feeders in the cities? What's kind of the difference? Well, why do we think they're being drawn to those urban feeders more than those rural feeders?
Well, so there are a couple of things that could be going on, and all we can do with this data set is sort of hypothesize what those might be. But one is certainly, yes, there could be more feeders around. So even though we're watching them at one feeder watch site, if there's 10 times as many backyards within that hummingbird's home range, perhaps there are a few extra feeders around too. Another thing is there's something called I think it's called the heat island effect. I think that's right now.
Yes, we had somebody comments about that earlier.
Yeah, so these urban areas may actually have a slightly more mild climate than the more rural areas at the same latitude. So that may be so maybe the hummingbirds are sort of, okay, I can live in this colder latitude, but I do prefer being near, a little more urban, a little bit warmer.
Me.
Yeah. And then another thing may be that there's the potential for a lot more non-native plantings in urban areas. So there may be things that are blooming or flowering a little bit later or at different times of year. There may actually be more food like that available in these urban locations compared to really rural locations that have much more focus on native plants as you move into northern latitudes. So those are really three different possible reasons, and we don't know exactly which one or the different importance of them, but and there may be other things we haven't thought of. So there's a lot. We've learned a lot from this one paper, but it does always open the door for more questions and more hypotheses to come up with.
Yeah, so, speaking of what Emily said, that we could probably just keep trading data. I have a thought on this related to stable isotopes, but we won't get into that. But I think there's other cool questions about how we could confirm this, but I won't go there, Emily. So you can
keep data to yourself today.
I will.
Well, anyways, okay, but I do have a question, me, myself, and I, that is not even sort of come with a random question. Do you have any desire or any dreams of really taking your FeedaWatch data and the data you've already evaluated through this study and doing any kind of comparison to the greater set of data on Anna hummingbirds that's just more random in eBird?
I don't know if we particularly are striving to do that with the Anna's hummingbird subset of data. It's always interesting to think about how these different large scale data sets relate to one another. So FeederWatch is one, eBird is one. There's also the Christmas bird count. There's the breeding bird survey. And so seeing how these different data collection methods and different time frames of data collection relate to one another is, broadly speaking, a very, very interesting question. It can tell us things about how our methodology is different, but it can also sometimes highlight biological differences. So maybe birds are increasing, a species could be increasing, look like it's increasing based on winter counts, but maybe it looks like it's decreasing based on summertime breeding bird survey counts. So there's a lot to be learned from those sorts of comparisons.
Yeah, that's a good question. That's like a
I vote
bottomless.
yes. I want you to do it.
Okay, I'll do it next
It
weekend.
sounds like a lot of work, but I vote yes.
And it's almost not like you need a wildlife biologist. You need like it's like a data analyst, there's like a bottomless supply of PhDs in data analysis, right? Because the other thing that's interesting to me to compare to is Project Feeder Watch is really good. It's got this, this really good layout of protocols, but it's also a citizen science one still, right? So you've still got backyard birders who, have varying levels of birding experience. And so comparing things like that to if you've got a study, say there's a graduate student studying Anna's hummingbirds and what did their data look like compared to, like you said, Christmas bird count data. Like there's so many different interesting ways to compare those data and how they're collected and what they're telling us, right? Like how consistent do you see things across the data, and trying to figure out why that is. Like it would be really cool if you could compare what you have to eBird and say, okay, I'm a scientist who's coming in and I want to study something that's on eBird and it's not going to really be captured by Project Feeder Watch. What can I do to kind of like clean those eBird data to where they can be better for what I'm trying to do? Like, can we learn from things like the way that Project Feeder Watch overlaps with eBird as to how we can better use eBird? I have no idea. Like that's a question for somebody, way beyond me. But there's so many interesting questions there.
Yeah, and there are data scientists working on eBird data and figuring out how to parse it to be able to see really beautiful trends in species at different times of year and very fine resolution changes based on where the birds are. So there is quite a lot that can be done with these different data sets. And folks who are better at it than I am are working on it right now.
No shortage of questions. Okay, I'm sorry. I have one more question to wrap us up, but I'm guessing we have more from Facebook. So
we have one big question from Facebook that I think is an important one. And I know, and Miss Emma, if you have to go, we completely understand. We told you 8-ish. If you have to go, we can keep going and answer questions and kind of wrap up naturally, or we can kind of end. But I do think this one is really important. So it's talking about those feeders and that supplemental feeding. And I'm gonna let you answer, and then I'm gonna add my one comment. Is as people see hummingbirds leave for migration, should we take our feeders up to encourage that migrations? And if we don't, do feeders lead to these trapped hummingbirds that could die under extreme winter conditions or weather conditions?
I am so glad you asked that. I actually wanted to talk about that earlier, and then we moved on to other things.
No, and that was my wrap-up question too.
Oh.
That was my exact thing that I was going to ask is what does that mean for the backyard hummingbird feeder? Do we take them up or leave them out?
So the important thing to remember about Anna's hummingbirds is that they are not a long distance migrant. They don't actually want to migrate to begin with. So these birds that are staying north, they probably wanted to do that anyway. And what the feeders are doing, it's not preventing them from moving. It's just helping them survive. So you end up with more birds that have this inclination to, hang out in the north. If it's a ruby-throated or a black-chinned hummingbird going through your backyard, those birds don't want to stay. They want to go. They want a meal and they want to get out of here. And a lot of triggers for migration are associated with temperature and the photoperiod, how much light there is during the day. Having a little extra food can actually prompt them to get going because they feel, okay, I've got the strength to do another burst of flight. So that's I can totally understand how it seems like, oh, geez, we're keeping the Anna's hummingbirds farther north. They want to be there anyway, because that's what that species does. Migratory species are going to keep going. And if anything, a little bit of food is probably encouraging them to get a move on. So don't worry about trapping birds just because you leave your hummingbird feeder out. You don't have that much influence over what these migrants want to do. They want to go.
That's such a good point because that migration is like, it's so embedded in them, right? Because that's how you can have a species that, or, you know, an individual that has never made that migration before, and they know where to go. You know, it's like, it's part of their DNA. It's part of who they are. And we talked, it's probably been a couple months ago, but my dissertation research was on eared grebes leaving from Great Salt Lake. And one of the things we looked at is, do they decide when to leave based on some of those densities of their prey? You know, like, oh, the food's starting to get scarce, and so they leave. And no, they're leaving when they're ready to leave. And if anything, it's like you say, you know, if they've got enough food to get ready to go, get those reserves, they want to go. So that's a great point to share.
Yeah.
So mine's more of a livestocky comment, because everyone knows that that's what my background is that I think that the key here on supplemental feeding, and it can be very relational to our livestock species, is you don't just quit feeding your dog, or you don't just quit feeding your goat in the winter. I mean, you just don't stop that process, because that's something that they're relying on. And so I think that if you are feeding, and then you get to this critical period of winter or breeding season, and you quit that feeding abruptly, that would be a much more detrimental thing to that species versus them hanging out and living there because you have a feeder.
Well, and so my comment then would go more from the keeping in mind that it is wildlife and not livestock. And the word supplemental is so important, because we're not like these hummingbirds that are hanging out at the feeders. They're not just eating at those feeders. They're getting those other resources as well. So I think that's important to realize, is that if you're supplementally feeding anything, it should be extra. It should be that bonus bit. And so if you do take it away, they're getting stuff from the environment still. It will impact their survivability. Like Emma was saying, those birds want to be there anyhow, and then you're helping them stay over longer. But it should always be in that perspective of this is extra. And so there's other things affecting them in the environment. And especially you should be managing the whole habitat well, right? Like that's where we talk about native plants and having your whole backyard to be a good resource of food. And the nectar is just a little bit extra.
Yes, that's true.
Yeah. But,
all right. Well, Emma,
right.
it has been a complete joy to have you online today on Cup Chat. It has been fun to hear you and Maureen enjoy data so much. And it was and super, everyone online seemed to have loved it. Wonderful questions, everybody. So anyways, thank you, Emma, so much for joining us. We did send out our flycatcher newsletter yesterday. So if you are not on our mailing list and would like to receive the flycatcher, make sure you go to our website and subscribe to our newsletter. That's a quarterly-ish newsletter that we send out. Sometimes we get a little bit behind. But we love to share what's going on with Birding with Extension. We don't send you a whole lot of emails if you are on our email list, I promise. So Emma, again, thank you so much for joining us. It was great to hear about your research and your paper. It was just, and your love for data and your love for the citizen science behind it was just overwhelmingly inspiring. That's a good word to say, inspiring. So thank you everyone for joining us. Oh,
everybody Maureen. Go join Feeder Watch, I think, right? Like, is that your closing statement? Everybody should go join Feeder Watch.
I have posted the link to Feeder Watch in the comments, so everyone can go check out the website and get the information.
Yeah, the Feeder Watch counting season just started on this past Saturday, so it's a perfect time to sign up. You'll get the whole season pretty much. So yeah, wonderful.
Well, thank you everyone. Have a happy Wednesday.
Bye-bye.